Did you know that Mount Everest, the highest peak on Earth, is still growing? Yes, you heard that right. This majestic mountain, reaching skyward from the heart of the Himalayas, is not done with its upward journey just yet. Standing tall at a staggering height of approximately 29,031 feet, Mount Everest is often seen as the ultimate symbol of adventure and challenge. It's a peak that has captivated the imaginations of explorers, adventurers, and dreamers from across the globe. But what if I told you that this lofty giant is not as static as it appears? While it's common knowledge that Mount Everest is the highest peak above sea level, not many people know that it's still growing taller. This isn't a case of the mountain getting a growth spurt or drinking its milk. It's about the fascinating and complex geological processes that shape our planet. From the outside, Mount Everest seems like a solid, unchanging monolith of rock and ice, but beneath its icy exterior, there's a lot going on. The story of Everest's growth is a tale of colossal forces, slow but unstoppable. It's about the Earth's crust, in a constant state of motion, pushing and pulling, creating and destroying. It's about the theory of plate tectonics, seismic activity, erosion and deposition. This might sound like a lot to take in, and it is. But don't worry, we're going to break it down for you, piece by piece. We're going to explore the intricate dance of geological processes that make Mount Everest a living, growing entity. So strap in for a journey to the top of the world and beyond. We're going to delve deep beneath the surface, into the heart of the Earth, to understand why and how this mighty peak continues to reach higher. So how exactly is the tallest peak on Earth continuing to grow? Let's uncover this geological mystery. To understand the growth of Everest, we need to delve into the world of plate tectonics. Picture the Earth's crust as a jigsaw puzzle, but instead of fitting together neatly, these pieces, known as tectonic plates, are constantly moving, albeit at a snail's pace. This movement is driven by the intense heat in the Earth's core, which causes molten rock in the mantle layer to move in a circular pattern, a process called convection. Now let's narrow our focus to two particular plates, the Indian plate and the Eurasian plate. The Indian plate, carrying the landmass we know as India, has been on a northward journey for about 45 million years. And no, it wasn't just out for a leisurely stroll. This plate was moving at a speed of around 5 centimeters a year. Doesn't sound like much, does it? But over millions of years, that adds up to quite a distance. Now, as the Indian plate moved northwards, it eventually collided with the Eurasian plate. But instead of one giving way to the other, they both resisted, and something had to give. That something was the Earth's crust. The pressure from these two colliding plates caused the crust to crumple and fold upwards, like a carpet being pushed against a wall, leading to the formation of the Himalayas, the highest mountain range in the world, with Mount Everest as its crown jewel. But here's the fascinating part. This collision wasn't a one-off incident. It's still happening even as we speak. The Indian plate continues to push against the Eurasian plate, causing the Himalayas and in particular Mount Everest to grow. The growth is slow, about a couple of millimeters a year, but over millions of years it adds up, leading to Everest's current height of over 8,848 meters. And this collision is not a one-time event. It continues even today, pushing Everest to new heights. While plate tectonics lay the foundation, seismic activity adds another layer to Everest's growth. Now you might be wondering, what does seismic activity have to do with the growth of Mount Everest? Well, let's dive a little deeper. Earthquakes and seismic activities are the rumblings of our planet. These are the Earth's way of letting off steam, literally. Originating from the intense heat and pressure building up beneath the surface, these seismic events can have a significant impact on the landscape. And yes, that includes our majestic Mount Everest. You see, the Himalayas, home to Mount Everest, are situated at the collision point of the Indian and Eurasian tectonic plates. This ongoing collision doesn't just happen in a slow, steady push. Instead, it's more of a series of jerks and shoves, causing the land to buckle, fold and uplift in what we call seismic activity. Now imagine the force of these seismic activities. These are not just minor tremors we're talking about. Some of these earthquakes can be incredibly powerful, enough to push the land upwards. And when the land uplifts, so does Mount Everest. However, it's not as simple as an earthquake hits and poof, Everest grows a few inches. The process is far more intricate and complex. The force of the seismic activity has to be just right. Too weak, and it won't make much of a difference. Too strong, and it could trigger landslides and other erosional processes, potentially even lowering the height of the mountain. So, the growth of Everest through seismic activity is a delicate balance. The right amount of force, applied in the right direction, can cause the land to uplift and add to Everest's height. And there you have it, the mighty Mount Everest, ever growing, ever changing, is not just a product of the slow, relentless push of tectonic plates. It's also shaped by the Earth's heartbeat, the seismic activities that ripple across our planet. So, seismic activity, spurred by tectonic action, gives a boost to Everest's height. But there's more to this story. Stay tuned as we explore further the fascinating processes that contribute to the growth of the world's highest peak. The growth of Everest is not just about rising higher. It's also about the reshaping that happens through erosion and deposition. Our planet is a dynamic canvas constantly being sculpted by the forces of nature. Erosion and deposition are two such forces that play a pivotal role in shaping the majestic form of Everest. Now, erosion is the process by which wind, water, ice or gravity transports soil and rock from one location to another. On Everest, fierce winds and the relentless action of freezing and thawing work in tandem to break down the mountain's rock. Deposition, on the other hand, is the geological process in which sediments, soil and rocks are added to a landform or landmass. As the eroded material is carried away by the wind or water, it is often deposited elsewhere, adding to the size and shape of the mountain. Weather conditions have a significant impact on these processes. For instance, during the harsh, cold winters, the mountain's rock can freeze and then thaw, causing it to crack and crumble. This is a type of physical weathering known as freeze-thaw weathering, which is quite prevalent on Everest due to its extreme temperatures. Wind, too, has a role in this geological drama. It can carry small particles away, slowly eroding the mountain. At the same time, the wind can deposit these particles elsewhere, contributing to the mountain's growth. And let's not forget the glaciers. These slow-moving rivers of ice carve their way down the mountain, eroding the surface and depositing large amounts of rock and sediment as they go. This process, known as glaciation, plays a significant role in shaping the mountain's final form. So, while the seismic activities might be pushing Everest upward, erosion and deposition are the artists at work, sculpting its majestic form, rounding its edges, carving its valleys, and adding to its mass. As the forces of nature continuously shape and reshape Everest, they contribute to its steady rise. Mount Everest, a testament to the dynamic nature of our planet, continues to grow and evolve. This towering colossus, standing tall and proud, is more than just the highest point on Earth. It's a living, breathing entity, shaped by the same geological processes that have sculpted our planet for billions of years. In our journey today, we've delved into the fascinating world of plate tectonics, seismic activity, and the interplay of erosion and deposition. Each of these elements plays an integral role in Everest's ceaseless growth. Like a patient sculptor, they carve, mold, and shape the mountain, creating a monument to Earth's incredible dynamism. The tale of Mount Everest serves as a vivid reminder of our planet's constant evolution. Its towering height, ever on the rise, is a testament to the relentless forces shaping our world. So next time you think of Mount Everest, remember, it's not just the tallest peak on Earth, it's a peak that's still reaching for the sky.